Isn't that your
All right.
wife's, like, sister?
Huh?
Not like your wife's sister.
No, we can be. It goes two different ways. So you can have a sister-in-law that is your wife's sister or your brother's
just like your
wife.
wife's sister.
No. Yeah, so it can also be your brother's wife. All right. Special right triangles.
Never mind.
This image right here is probably the easiest, simplest way to remember them. But there's two different theorems that they relate to. So we give you both theorems. So first things first, a 45, 45, 90 is what type of right triangle?
Isosceles.
It's an isosceles right triangle, right? So what do we know about all isosceles triangles, not just isosceles right triangles? What do we know about any isosceles triangle?
They're important.
They are important.
Two
Michelle?
sides are congruent.
Yeah, the two legs or two sides have to be congruent, which in the right triangle we then call the legs. And what else? If two legs are congruent?
The two base angles are congruent.
Two base angles are congruent. Now, where the special comes in is when it's an isosceles right triangle, we can find the hypotenuse by just taking radical 2 times the side length. So once you know the side length, it's just radical 2 times that, or approximately 1.4, because radical 2 is approximately 1.4. So it's approximately 1.4 times the length of the leg. Yeah.
Do you care if we just use 1.4? Do you have
Yes,
to use
because
actual radical?
you need to use the actual radical 2. And a lot of times, say the leg is like 7, you might just say it's radical 2 times 7 or 7 radical 2. But if I want to bring the 7 in and combine it all to simplify this, this would be 2 times then 49, which would then be 98. So that actually be radical 98 if I wanted to put it all into radical form. Or I could have just left it right like this, 7 radical 2. Now 30, 60, 90 right triangles, it's a little bit harder to remember that special rule, but it still involves the radical 2. A radical and a 2. I said that too quickly and I said it the exact opposite of what I wanted to say. Isosceles, the special isosceles right triangle, think of it as having 2 legs that are the same, and that's why we use the radical 2 and the leg. When we look at the 30, 60, 90, the hypotenuse will actually now be 2, not radical 2, but just 2 times the short leg. And we actually don't care about the long leg. We only need the short leg. But if I have the long leg and not the short leg, then I have to find the short leg. So that's the problem. If I'm given the long leg, I have to find the short leg, but I can calculate both the hypotenuse and the long leg by only using the short leg. So the big thing here is your longer leg compared to your hypotenuse. Which will be longer, the longer leg or the hypotenuse? The hypotenuse, right? We know that. Which is bigger, radical 3 or 2? 2. So like people often switch these up. So what I've realized I just need to make you think about now is which is bigger, radical 3 or 2. 2 is bigger, so that has to go with the hypotenuse. So then radical 3 has to go with the longer leg. Any questions on the theorems? I think we've probably already seen these before, hopefully. So when we are given the leg length of an isosceles right triangle, we can easily calculate the hypotenuse by taking radical 2 times the leg. So when I do that, I get 9 times radical 2. If I wanted to put it all together, this would become 2 times 81, 162. It would be like a radical 162. But we're not that worried about that. If I wanted the decimal form, now radical form is always like the most accurate. But if I was asked for decimal form, this would be approximately 12.73 if I round. So try B on your own. which should make your life a whole lot easier if you realize how the radicals work together.
Wait, was that 12.3?
I'm confused.
I got 12.7279220. So 12.73 approximately. So in B, why do I say that B is easier? It's B'sier.
Please shut up, Megan, please.
Because it comes out to an integer.
Radical 2, when multiplied with radical 2, so I know that my hypotenuse is going to be radical 2 times the short leg, which is going to be radical 2 times 2 times radical 2. A square root value times the same thing comes out to be what? 2. So this actually is just 2 times 2, and it comes out to be 4. Any questions?
Anytime you say leg, like in reference to a triangle, I think of a triangle with legs. And I can't.
So, ironically enough, on my Facebook time hop this morning, comes up and says, "Do you remember this?" And it was a post about school, which most of my posts are about school because that's my life. And so I was working with a student, and I was trying to talk about right triangles. And I said, so if this side's the leg and that side's the leg, what's the other side? And without missing a beat, they said, the arm. One of those moments. Try this on your own. Now it's 5 radical 3. So now it doesn't have a radical 2, it has a radical 3. How is that going to change this? Try this on your own. So Scarlett, my short side that I'm going to plug in here is what?
Bless you.
Thank you.
I am lost.
I asked that in a way that I intentionally made tricky.
Yeah.
If it's a 45, 45, 90, we don't have a short side, we just have side, right? So the only thing I have to plug in is the side length. There's not short side, long side, anything like that. What do I plug in to my whole radical 2 times side length?
Again, I'm lost.
When?
5 and the little squiggle and 3.
If it tells me the leg length is 5 radical 3, this S is for side length, but that is just the leg length. So it just becomes 5 radical 3. And I don't really need these parentheses. And I'm going to reorder this to put my radicals next to each other. Because multiplication is commutative, I can put them in any order I want.
Let's do it 6.
He multiplied the 2 and the 3, but didn't
Oh,
erase the
good. I did a step that I didn't. Crap! Stop working ahead. You know when your brain just like wants to do what it wants to do? So now, and I just gave this away. I hate myself. Brian, look, I do that more often than I would really like to, where I like my brain thinks the next step, I write the next step, and I didn't want you to see it
I
yet.
figured it out.
Brian, what can I do?
Would it be 5 times radical 6?
Why?
Because you multiply the 2
Because he said
radicals
he'd do it.
together.
When I have 2 radical values. Now the danger is coming when people try to multiply radical and non-radical, but when I have 2 radical values, I can really write them under the same radical, which really I can then combine them since they're being multiplied, and it becomes radical 6 times 5 or 5 times radical 6, whichever way you would want to write it. We like the integers first, but that doesn't mean that it's right or wrong. This is just the quote-unquote nicer way to write it. Straveler.
Do you know when we're going to be getting our chapter 6 test?
Yeah, I wanted them to be back to you today, but then this morning I had about 9 things I did not anticipate come up, and I did not get the grades done, like posted and everything, so I just can't give them back to you
I
yet.
didn't know you counted.
So tomorrow. You'll have them
Can
back
you
tomorrow.
tell us, like,
Not everybody, so I'd prefer not to. I mean, most of you were doing rather well. So minor mistakes was all I was really seeing. Now working with the special, right? This is still not special. Working too far ahead. One last one here. When given the hypotenuse value, because we always have to be able to do it both directions. So now when given the hypotenuse value, obviously to isolate my x here, Carmen, what am I going to need to do?
Divide by radical 2.
Divide by radical 2. Now I get a value of x equals 6 divided by radical 2. That's kind of weird, right? Have a division by a radical.
You can't. You gotta get rid of it.
Hold on. So what could I do to get rid of the radical in the denominator? Ethan?
You could multiply by radical 2 over radical 2.
Ooh.
Times 1.
So if I multiply by radical 2 over radical 2, that's really just multiplying by 1. And my value comes out to be radical 2 over 6. 6 times radical 2. Might as well put the 6 first and write it accurately. Over 2. Now, how do I deal with this? Because I have a division by 2. And this is where a lot of people get kind of tripped up with how do I simplify this. Calvin?
Don't you just divide the 6 by the 2 and then you get 3 radical 2?
So, does the radical 2 need to be divided by 2?
No, because they're not being added.
That's where people get confused. This is multiplication. And division and multiplication are actually the same thing. Now we know they don't do the same thing, but they are the same operation technically. So I can actually write this out as a string and say this is 6 times radical 2 times a half, because I'm really taking half of 6 times radical 2. So I can multiply that half by whatever I want to. I could have divided the radical 2 by the 2, but since this, well, I can't technically because it doesn't work out. So I can do the 6 divided by radical 2. So this just becomes 3 radical 2. Any questions there? If these were added, we would not be able to treat it like that. We would have to divide both of them individually. But since they're multiplied, I only need to divide one of them because it just happens like in a string of multiplication. Preguntas? How was camp, by the way?
Alright.
It was wonderful.
It was an experience.
I got lucky.
Yeah, we didn't get to do the Tango Tower. Yeah.
I know nothing about what you're talking about because I've never been there.
It's a 50-foot like rope climb where you climb in the air on like a big cargo net
Yeah.
to the top of like a tower.
That's pretty sweet.
Only 2
Yeah,
people.
but like three groups didn't get to do it.
So it leaves you wanting more, and maybe you can go back. So,
But everyone else got
hey, solve this out on your own. If your hypotenuse was 10. If your hypotenuse was 10. In a 45, 45, 90. Does 8th grade play tonight or 7th grade play tonight?
We played it.
And kickoff 6?
7.
7. I thought kickoff was 6. What's at 6? The tailgate stuff?
I think it might be like the pool valley. That's at 3. No, that's
Yeah,
at
that's
3.
a 3.
So if I'm there at like 7, maybe slightly after, that's good.
Yeah.
Okay. Kilbourne, right?
Don't
more
waste
field.
your money though.
Making sure. Yeah, Coburn High School. Yeah.
To sit on the side of it.
I'm going to be like on the field probably. I'm going to be taking pictures. Yeah, I got to go for yearbook. I need a better camera. Mr. What? Yeah. I should get like one of those vests and one of those like weird hats that the news people wear. And, yeah, with like a pass or something in it. Well, that's kind of lame. You should have changed it up. Who can walk me through this process? I would love it to be somebody I haven't really talked with yet. Any volunteers I haven't talked with yet? Emma, we haven't really talked math yet. What do we need to do? So I've set this up as far as is the easy.
You divide both sides by
Hopefully, bless you. Hopefully we don't have any questions how I got to here, but I totally agree, Emma. We divide both sides by radical 2, but I can't divide by a radical in the denominator, so I get s equals 10 over radical 2, and I have to do something. What do I have to do?
You multiply by radical 2.
Multiply by radical 2 over radical 2. Now, I want to know if anyone has thought of a shortcut yet of how we could just get to our hypotenuse without doing this whole process, because in the end, do you want to just jump to what you got for your answer? We get 5 radical 2, right? So up here, we ended up with a hypotenuse of 6, and we got 3 radical 2 for the leg. We got a hypotenuse of 10, we got 5 radical 2. We could make our own formula, Brian.
It would be half of the hypotenuse, like square, the times the radical 2.
Right, I was just going to make you say what it is, but we could say leg is, you said half of the hypotenuse, hypotenuse divided by 2,
And radical 2.
times the radical 2. So if you don't want to work the whole process, the process that we carry through will stay the same on every single triangle that we plug in, as long as it's the 45, 45, 90. So I would just advise, use this formula. Cut the hypotenuse in half, multiply by radical 2. You're done. Any questions? So, we have a softball diamond here.
That's cool. What just happened?
RGB. Your computer, well, not most, I guess most computers these days are HDMI, high definition, multi-something, I want to say multi-interface. Old computers are red, green, blue feed. Just like your eyes really only perceive a couple colors, computers really only need fed with 3 colors. How much red, how much green, how much blue for each pixel, each box. So when this gets knocked sideways accidentally, and then when I fix it, yeah. So it will like delete the colors one at a time. If you just barely pull like a couple of the pins out, it just screws up the color feed.
That's cool.
So the distance from base to base is 60 feet. So from home to first, or first to second, second to third, any of that. How far does the catcher have to throw the ball from home plate to second base? Brian?
No, why does it default to like pink?
I don't know.
Because it takes all the green out, and that leaves magenta.
Oh, yeah, if there's only red and blue, the mix of only red and blue makes magenta. Or what you're calling
It's just
pink.
the first color it deletes.
Oh, okay.
However my computer's hooked up, it deleted green first.
But normally it's pink. Why is it not like the other one?
Don't know.
Because it deletes green.
Also,
first and fixes it.
if you sit in a room that has a red light bulb and only a red light bulb, because your eyes only really perceive red and green,
We learned this again,
huh?
We
You
learned
learn
this
this at
again.
camp.
Yeah.
Night.
You then and your colors are all screwed up because your rods and cones have been goofed
That's
up.
what I want to do. Screw up your rods and cones.
So, we know what about a baseball or a softball diamond? What do we know about this? I hate really calling it a diamond, but ooh, yeah. Sorry, we haven't talked. What up, Carmen?
I have.
Do you play softball?
I used to.
I thought so.
It's a 45, 45, 90 triangle.
So, really, a baseball diamond
It's a square.
is a baseball square.
See, it says that a high school softball diamond is a square.
Yeah. So this whole like diamond is kind of like it's not. It's a square. We might as well call
I
it.
consider a diamond a pin.
The softball square.
You know the diamond where it's got the 2.
Yeah, you're talking about a 3D diamond, though.
That's what a diamond is, though.
Well, you're thinking of the two-dimensional cross section of a three-dimensional diamond.
Yeah.
But technically, that diamond has been cut. So really, it's a diamond is kind of a negligible argument.
Just like a star.
Yeah. So we know a 90-degree intersection from first baseline to second baseline. So then we have a 45, 45, 90, because if this was 90, then this would be bisecting it. So what we really have is a right triangle with legs of 60, And hypotenuse, why did you break up that 6?
Because it's sad.
Hypotenuse will be the distance from home to second base. Brian?
It would be 30 square root radical 2.
30 radical 2.
You just use the other forms. Oh, never mind. It's like I messed up.
It's like,
Wait.
Thank you for correcting him, so I didn't need to. So wait, our hypotenuse, our formula is actually...
Oh, I got it.
Save yourself.
Alright, it would be 60 times radical 2.
Yeah, it's really your radical 2 times your leg length, or your side length, which is really 60. So we will get 60 radical 2, or approximately, if we just wanted to round a really ish number, if radical 2 is about 1.4, you can kind of think of it as close to 1.5. Yeah, so this is going to be under 90 feet. So if you were trying to try out for catcher, you'd want to make sure I can throw the ball 90 feet, because that's the catcher.
Catcher.
Because you want to throw the ball from home plate to second base. That's the furthest throw that a catcher will ever need to make. Because if you're the catcher, you're not throwing the ball out to the fielders. You're throwing it to one of the bases. So the furthest throw would be under 90 feet. Now, if we actually calculate this and do 60 radical 2, we get
Ryan is true.
84.8. So pretty close approximation if we use slightly under 1.5.
So if you get your 90, you could throw 84.
Yeah, exactly. If I know I can do more than what I have to, I will be okay. Try the Goddard on your own. To the nearest foot, to the nearest integer value of a foot. You're building a path along the diagonal of a 100-foot by 100-foot garden.
what was that?
A beeping noise.
Was it the fire alarm?
It happens. We're all saved.
I didn't mess up this time.
You didn't mess up this time?
I used the right formula.
So remember it says to the nearest foot, so you cannot leave it in radical form.
Oh,
So I will tell you, radical 2, if you want to know the decimal beyond the tenths place, is, radical 2 is 1.414. If you want to know it a few decimal places. No, that's not precise because it's 414 21356.
2.
4, 2.
That's probably rounded, so it's not 2.
So, Brian, if I try to reason through this without using a calculator, can we do it?
Yes.
Yeah, because we're going to get the hypotenuse first in radical value as what?
100 radical 2.
100 radical 2. Now, if I then replace radical 2 with something at least to the hundredths place, because I need to round to the integer, I actually am going to go ahead and do it to the thousandths place just to have the extra value there.
You get like 140 points.
Ooh, careful. We get 141.4. So rounded, because when we multiply by 100, multiplication by 100 just moves my decimal 2 places.
Oh, okay.
So this rounded to the nearest foot is really 141 feet. Off by a foot, man. 12 inches.
I got that, but you didn't let me use a calculator.
But if I know this value, multiplication by 100. So that's what I was saying. If you know that this is 1.414, normally that's enough decimal places. But don't just use 1.4. That's very approximate. You could, for most of this math, think of radical 2 as as 1.414. If you think of that value, that's probably specific enough for your radical 2. But if you want to make your life even easier, just plug in radical 2 to your calculator.
Yeah.
Questions? 30, 60, 90. It depends on your brain whether or not you actually think these are easier. I think they're easier because how did that did not capture.
Dude.
There's more to figure out, but it's still pretty straightforward. There we go. Everything references back to your short side. What is double your short side? Is it the hypotenuse or the long leg?
The hypotenuse.
The hypotenuse. So this throws people off. Here's the misunderstanding. I want to tell you guys what not to think. You cool?
Oh yeah, I was just trying to figure out if I could whistle.
You want to try?
Yeah,
think
it doesn't work tongue is good.
Yeah, you should not. Well, you kind of use your tongue. But I just figured I'd let you figure it out.
I'm just thinking about it. Okay.
All right, but 7th grade is an AO, so we will make a whistle choir at some point. Bring it back. Bring it back. So, here's where people get confused. And I want to tell you it now, so when you think this, you tell yourself it's wrong. They say, well, 30 compared to 60, the long leg must be double. No, that is a trap.
What?
We're going to talk about trig here in just a couple days. The angle size is not directly related to the lengths. So go back to your theorems and remember that your long leg is not double, it's radical 3 times the short leg. People try to compare the angles and they think the angle sizes relates to the leg sizes. That's not true. We'll talk about the trig of why that happens. So we know that the hypotenuse will be double my short leg. So honestly, first thing I would do here is say F is actually 2D. Because it's double my short leg.
And it's 2-dimensional.
Ha. So now the struggle is figuring out the short leg since we aren't given it. Alright?
I tried to do this. Is this wrong? I did 5 equals radical 3 times d.
That is not at all wrong. We know that the long leg is radical 3 times the short leg. So my short leg, which we're now calling d, to isolate that becomes, Michelle?
Divide both sides by radical 3.
We divide by our radical 3. I should shift this so you know that we're not talking about the guy. And d will become 5 radical 3, which then, because we hate division by radicals, like we did with the radical 2's, we need to multiply by radical 3 on top and bottom. This becomes 5 radical 3 over 3. And this will then tell me that d is actually
1 2/3 radical 3.
yeah, or we could just say 5/3
Fancy.
radical 3.
No, it's not fancy. It's improper. Improper is
So there's this really interesting book, and I forget what the exact title of it, but it's we were eating in Westerville, and there's this new restaurant there, and it's just filled with books. Like their whole thing is like, it looks like a bookshop, and it has to do with how high society used to live, like a long time ago. So like the 1700s, how like fancy people back then used to live. It's really interesting to look at the difference of lifestyle, because back then to have a toilet inside, not running plumbing, but to have a toilet inside was a huge, like you had to be really pretty darn fancy to have an indoor toilet. And even then, somebody had to go clean it. But it's just interesting the comparison of like, it's only been a few hundred years. That's not that long. and life has changed dramatically. So then if F is double D, we can really just say, I guess I might as well change color, that F is 2 times 5 radical 3, or sorry, 5/3 radical 3.
Wait, but we don't have to figure out F.
For the next problem.
Yeah, but I'm going to do it anyways. It's like, you know what I mean?
Oh, no.
All because it doesn't ask for it doesn't mean we shouldn't do it.
I know.
So then we can make this 10/3 radical 3, and that would probably be where we stop. And that is our 2D value. Any questions? Try.
You just did it.
Oh, yeah. I need to go back and change these notes. They're not hard enough.
That's a problem.
It is a problem. I've already got my plans set for us to not do anything more than this today. So let's just work on your homework.
Thank you.
I saw you at Kroger on Sunday.
Yeah.
Cool words. Yeah. What was I doing? Probably buying stuff to grill, wasn't I? 'Cause my sister was still in
Please
town.
excuse the interruption. Could I have
Why do you
Brian
say hi?
Strickland to the office? Brian?
Oh, I was about to say I didn't see you. I didn't notice you were there.
2 years ago, I saw you at Target.
Did you say hi?
Brian's my
No,
naughty
but you were
boy.
wearing toe shoes.
I saw you.
Yeah, I
at the
love my toe
graduation.
shoes.
Brian's naughty.
Wait, how did you know that?
I'll wear them here sometimes. They don't smell too
What
bad.
are those?
They're literally shoes where like you have toes. Like toe socks. You just have toe shoes.
Oh, mine was flex toes.